All right, so good morning, everyone again. My name is Alexander Egurnov, and I want to talk to you about testing in Go with Ginkgo and Gomega. So first, a bit about me. So I work as a team lead in backend department in Verve Group Europe, and I've been coding Go since 2016. I've seen all kinds of projects, big, small projects with hundreds of lines of code, with thousands of requests per second per server. I've seen projects with tests, without tests, with useful tests, and with tests which really shouldn't have been there in the first place. So now about the company. Verve Group Europe is a mobile advertising technology company, and the product I'm working on, and this will be important for the presentation today, is an API service. It's an ad exchange. So this puts some specifics into what we are testing. And we are backend heavy. We don't have a front end for this product, and we use a bunch of technologies. Quite typical in the industry: Go, MySQL, Kafka, Redis, Docker, Kubernetes, all kinds of CI/CD scripts. So it means that we are not really testing front-end part here or anything related to that. So that being said, let's see what we have in store for today. So first, I'm going to talk about general approach to testing in Go, what options are there, and how can you choose between them. And I'm going to focus a bit more on Ginkgo and Gomega, some specifics about how they work together, some typical mistakes you may make in the beginning and not in the beginning, as it turns out, and share some personal experience of using these libraries for more than 2 years now. Also, who is the talk aimed at? So I expect some initial Go experience, probably advanced Go experience, and some initial experience with writing tests for Go. Ideally, you're working on a growing project with some growing pains and are eager to try something new. So if you match this description, you'll probably get the most bang out of this talk. So let's get to it. So what options are there? What people usually use for testing? So outside of competition, I would say I've often seen people using other languages to write tests for Go code. So Java and Python are among the top choices. This approach is viable, but has a number of problems. So first of all, you need to write some code twice in Go and your language of choice, which adds to complexity, developing stuff, and maintaining your CI/CD pipeline. So you have to support 2 runtimes for Go and the other language. And this also puts a strain on the skill requirements in the team. So people joining the team need to be comfortable with both languages. And every time I've seen it, the person who initially developed this test suite was the bus factor of 1. So after this person leaving, people usually were not developing the tests any further. So this is a huge risk. So let's see what solutions we have inside the Go ecosystem. So looking at JetBrains Developer Survey of last year, you can see that built-in testing is taking the lead, and by far the most popular framework, with Testify, Ginkgo, and Gomega following at short distance. So here I've highlighted only the testing frameworks and other libraries which are related to testing, but are not testing frameworks in themselves, are not of much interest for us today. There is a new survey, so this year's results already in store, and you can see that built-in testing is still leading, Testify gaining a lot of traction, and Ginkgo and Gomega also getting closer to the top. So you see that although they're not the most popular, they are getting some traction as well. So let's see what the standard package, the standard testing package, has to offer. It's standard, its batteries included, you don't need to install it, it's already there. So it's quite simple, and with being simple, it does make you write a lot of code. So there's no assertions library, a lot of things are just not there, and you know that a Go community likes it this way. So let's see a typical test written with this package. You can see that you can do all kinds of checks. If you want to skip the test, if you want to do some preparations, you can do it yourself. Obviously, you can organize test cases and run subtests, but everything within all the checks, you need to do it yourself. If you want to be fancier, if you want to compare bigger structures, you need to think about this as well. So you can notice, reflect, the equal and other functions which support the test. So this adds quite a bit of code to the test and makes it, in my opinion, a bit harder to read. So here you see typical examples of what you would write to simplify your life using the standard testing package. So you can have all kinds of checkers, validators, and you need to write your own setup and tear down code. Let's see if we can improve on this and how. So I offer to start with looking at Testify library, or a set of libraries, set of packages, if you will. And the first two, Asset and Require, are Assertion libraries with very slight differences and exactly the same API, which will allow you to make your assertions in a more powerful way without writing all the tests yourself. Mock allows you to mock to create fake objects, and Suite allows you to make your tests a bit more complex with custom setup and tear down. So Testify complements the testing library, the standard testing library, pretty well. So it's quite, yeah, it doesn't try to replace it. That's the first thing you need to know and understand. It does allow you to use its rich API, quite on par with Ginkgo, I have to say. And you can write your setup and tear down using Suite package, and you can use mocking from mock package. I would say that convenience of using API is a question of choice, really. And some might like it, some might not. I've noticed some problems with API design, which forced me to move forward from that. Another thing which could be improved is extendability. So you can't really plug into this library and extend it with your own code in a lot of places. So let's look at the typical example. So this is the same test rewritten with some Testify functions. You can see there's require and assert in the subtest. So now it makes for a bit more readable tests. There's still a lot of boilerplate. And I've mentioned API design problems before. So let me highlight it a bit. So the most typical problem with API of Testify is switching the places of expected and actual results. And because in different API methods, they stay in different positions. So you do it all the time. So which is, it's not necessarily a big deal, but highlights some API design issues. So what's in Ginkgo and Gomega, which is not in the previous two? So first of all, Ginkgo being a framework and forcing structure on you, it makes your test a lot more structured, a lot more easier to separate from one another. Setup and tear down routines are very well thought of. You can build complex setup and tear down. You don't need to create everything every time. You can share setup and tear down between branches of testing. It offers quite a rich DSL, so domain-specific language. So your test can actually read pretty close to natural English sentences, which makes it quite pleasant to look at. It's also quite extendable. You can write your own matchers, and more on that later. So you can actually use all of the power in Ginkgo and Gomega, all other API functions with your own functions. So you can extend it quite a bit. It can get a bit quite complex, but complexity can be managed, I believe. And yeah, with great power comes great responsibility. So let's see, how can you choose between these three? So first question I suggest you ask yourself is, when do you need to start choosing? So I would say that when it becomes too hard to read, write, or change your tests, when your testing harness grows too large, when you set up and tear down, assertions, helpers, checkers grow bigger than your actual tests, when you need to write a lot of API clients and you need to support them as well, when the logic becomes obscure, when it's actually harder to read your tests than your code. This is when you really need to think if you're doing it right and if you need to use a tool which is a bit more powerful than whatever you can write yourself. Another problem with your own harness and with your own testing code is that sometimes it needs testing as well. So I've seen a number of tests not being effective because they were just not working. So what is harness? Harness is like the things around what you really want to do. It's these ropes and clasps all pieces around you or around your working code, which help it progress, right? In case of tests, it's all these supporting functions, all these supporting libraries you use, which make your task writing tests easier. So let's see, why would you want to pick another testing library, not the one you're using right now? So again, to address problems we've identified with the previous question, if you want to simplify reading and writing your tests, if you want to remove code duplication, if you want to make your tests shorter, more readable, if you don't want to reinvent the wheel, rewriting things which are already there, written by someone, tested and supported by the community. Yeah, as a bonus, you get good portability. So whatever you learn about a library, you can always take with you. So working on code, you can't always take old code into the new project. So that's a list of benefits you can get out of it. One word of warning I want to say about duplication is that you don't always need to go with maximum deduplication, right? So a lot of people already know about dry, don't repeat yourself, try not to rewrite code, try to reuse code. For tests, an opposite approach might be quite useful, called DEMP, descriptive and minimal phrases, which means that you actually want to read your tests and understand what's happening. You don't need it to be super short, super reusable. So some tests, the more reusable they get, the more complex they get, and this doesn't really work well for them. So as usual, Go proverbs to the rescue. So clear is still better than clever. Hasn't changed since 2019, sorry. And if you haven't seen that, if you're just beginning your Go journey, I've left some links here, so I believe the PDF will be available later. So I suggest you go check out these links and get comfortable with Go way of doing things. Also, an important concept going forward is test pyramid. So not all tests are created equal. Different tests perform different functions, and I believe that different tools need to be used for different tests. For the purpose of this presentation, I know there's not really a agreement in the community on what to call what. So for the purpose of the presentation, I will have unit tests as tests which test some small limited piece of your code, typically a function or a structure. So they don't try to go any deeper than that, and they shouldn't. Integration tests are aiming at testing several components. So the way they interconnect, the way they play together. And end-to-end tests in today's presentation are tests which test the whole product, probably treated as a black box, don't really try to get into detail and only care about the inputs and outputs on the bigger picture. I would say that my personal choice is still using testing and testify for unit and integration tests, and iterate tests, bigger complex tests, is where Ginkgo and Gomega really shine. So let me tell you why. So first, looking at what is Ginkgo and Gomega. As I already said, Ginkgo is a framework. It puts some structure onto your code. It dictates how to write your code and controls it. So you don't control it to a great extent in the right time. Gomega, on the other side, is an assertion library. So it doesn't enforce any structure on you. You can actually use it without Ginkgo in your normal standard testing routines. It just helps you make assertions. So, and you fully control it from within your code. So what specifics are there to Ginkgo and Gomega? So now we're getting in the part where there is going to be quite a bit of code. So get comfortable with it. So first of all, you build a test suite. So this is a thing which gathers all your tests and builds a testing tree, more on that later, and runs your code from within a standard library test. So Ginkgo test, Ginkgo and Gomega tests are fully compatible with standard testing, so you don't need to switch in one big leap of faith. You can start writing your more advanced Ginkgo and Gomega tests right alongside your normal testing package. So I've just mentioned the testing tree, so I probably owe to tell you a bit more about that. So the way Ginkgo approaches testing is that it builds a tree of functions, closures, essentially nameless functions, and you can control which tests are getting executed, which tests are not getting executed, how setup and tear down works. So you first build this tree. This is the first step, and only then, after it's completely built, you start executing it. So this is quite important and leads to a number of gotchas for new programmers. So as always, closures can complicate things quite a bit, but once you get comfortable with that, they're not really a big deal. Let's see about setup and teardown routines Ginkgo offers. So it allows you to put some code before, just after, and after. And because this is a tree, so this just before each is guaranteed to be executed after all the before each, which may be on the path to your test. So in this example, you see there's two tests introduced with a keyword specify, with a function specify, and their contexts. So these are the tree nodes which are living inside one another. So with this setup, we have a full set of functions in the first context and a full set of functions in the second context. So you see for the first test, only the functions from the first context are getting called. But when we're going to the second test, first, before each functions from the first context are getting called in order, and then just before each functions are getting called. So this is really useful when you want to first create some objects and probably override them, going deeper into your test tree, and only then you start applying these changes, storing them in the database, for example, or finalizing them in some other way. And cleanup is executed in a similar way in reverse order. And there is also something you can run before the wall suit and after the wall suit. So which makes it quite comfortable to write bigger, for example, database setup and destruction routines. So something you only need to do once for your wall test suite. So I said you can, you have limited control on what's getting executed, and it's quite comfortable to switch functions, switch the whole branches of your test on and off. And Ginkgo has a really good way of doing this with focus and skip and pending. So you just prepend one letter to your existing testing method. So in this case, it, and you can focus on your test. You can also, if you don't want to run a test, you can leave it pending, then whatever happens in this test will not bother you while you are debugging something else. So obviously for CI/CD purposes, none of this will work. So whenever there is a focus test, Ginkgo will not return a zero return code. It will be something over 100. So you will not accidentally commit it to CI. But while you're working on tests, and if you have a big testing tree, this helps you focus on one part without worrying too much, breaking stuff in other things. Right. Another very useful feature of Ginkgo itself is being able to control your output. So I think we've all been in a situation where you can't really see what's happening in the console output because there's so much being printed. So you can't really see signal in all the noise. So this neat little option allows you to control what is being written and when it's being written. So in default case, it will only print when there is an error in the test, and only then will you see. So if your tests are good and green, it will just not print anything. So quite useful for keeping your precious screen space clean. Right. Now let's see what Gomega has to offer in its own. So first of all, you can use it independently, as I already mentioned. Here you see a standard Go test, and you see I don't have Ginkgo in here. I just have Gomega. I create an object new with T using the testing T object, and I can do my assertions, which read quite natural. So except for this small G in the beginning, and I can actually understand what's happening here without knowing what API does, right? I can just check that 5 equals 5. So with that being said, I also mentioned matchers already. So matchers are a way, actually an interface inside Gomega, which allows you to validate assertions. You can write your own, you can use existing, you can combine them in very creative ways. So here I've listed the most typical matches you can expect from a typical testing library, comparing numbers, comparing strings, so comparing objects. And there is a special syntax for checking errors. So you can see that you can expect error to not have occurred, or some task to succeed, or expect some function even to panic if you use panics. So really very flexible. So a lot of ways to check the same thing, but they can read very naturally. So Ginkgo Gomega being quite advanced allows you to do a number of advanced assertions, something you can't really write that easily yourself. It can help you validate that arrays have the same set of elements regardless of their order, that a certain array contains a certain element, or that a certain element is an element of a certain array. So a lot of power with that. It also works with channels pretty neatly, so you can check that some things are being sent, received, that the channel is closed in a very natural way without actually working with the channel yourself. So it still fits in one line. And yeah, there are also a number of functions working with maps, which make iterating maps a rare thing for you to do in your tests. So also quite comfortable. Two powerful matchers actually are eventually and consistently. So if you ever find yourself in a situation where something happens after a bit of time, so to put in a timer on it is usually not the right solution, because it may happen before, it may happen after. If you find yourself in a very constrained testing environment, whatever timer you might think was meaningful on your own development machine will absolutely fail in this environment, because it just takes so much time to get scheduled. So eventually it consistently help you reduce this strain. So they will test that something eventually happens, or so that there is a change in the result of whatever you pass to it. So either a channel or a function, or that there is no change with consistently. So you can set time limits, you can set how often this needs to be checked, and very naturally work with all kinds of asynchronous code. So this is a very convenient set of matchers. I also said you can combine matchers, and this is where Gomega really shines. So you don't need to write repeated assertions about the same thing. If you need to make sure that a number is both greater than some other number and less than yet another number, you don't need to write two assertions. You can combine them together. And then you also understand that this is related to the exactly same object under test. You're going to write your own, in this case, in range. It combines two checks in one name, and you can use it with normal assertions, as in expect 5 to be in range 3 to 6, which allows you to extend, actually, right? As I said, it allows you to extend matcher library with your own matchers. So you can do it with every assertion. So almost all of the standard Gomega matchers, they can take another matcher. So as you see here with contain element, I actually want to see in the array and two elements, one between 10 and 20 and another between 40 and 50. I don't really care which elements in which order they come. I just need to know that there are such things. And you can write it in just actually one line. Here it's broken into several lines for readability, but makes very powerful domain-specific language. Right. You can also transform stuff. So if you ever find yourself needing to access a property of some object, you can do it with matches as well. So this allows you to write very powerful matchers. Let's hear some typical mistakes. As I promised, there's quite a number of ways to shoot yourself in the foot with more advanced tools. So let's quickly go through the list of these typical mistakes. So probably the most typical thing, and this also affects assertion libraries in Testify. When comparing numbers, there are hidden typecastings. So you see here that a float number will be not equal because the types are not equal with an integer number, 5 being an integer constant. So, but there is a gotcha if you try to use B equivalent, so which will try to cast them to one another, that when casting a float number 5.1 to an integer, you will lose this precision and they will actually seem equivalent. So the solution to this problem is fairly simple. Just always use B numerically if you have numbers which can be different types. So I suggest you just always use B numerically with numbers. It provides you a number of comparison options. So they're given as a string. In this case, it's equality. You can have greater than, less than, greater equal, less than equal. And you can also have this tilde comparison, which checks with some precision. So another typical way is to look for an element which is supposed to be contained. And you might be tempted to look for an element in a string, but string doesn't consist of substrings. String consists of characters. So you need to use contain substring for that. So another typical mistake I've seen. So eventually, as I said, is very powerful, but the simplest way to make a mistake with it is when you pass a result of the function. So you see here in the line, which is highlighted, is ready, is being called. So the result, in this case, false, if we're calling it too soon, will be just stored and will never change, right? What you really want is you want to pass a function which is dynamic and can change the result and will be called every time. So also very easy to make this mistake, very easy to fix it when you know where to look for it. Closures, as usual, also pose some threat if you don't know what to look for. So the most typical mistake is passing a value which is not being initialized properly. So in this case, if you run this function, the value of v from the outside, the 5, will potentially be overwritten. So the way Ginkgo runs tests is not deterministic. So the second test uses v2 can actually run before the first test. And quite expectedly, in this case, the first test will not pass because the value of v is already changed. So a good advice is to always set your variables, not when you declare them, but in the testing functions, in before each, in it, wherever you feel they should be, just to make sure that somewhere on the path to this test, this assignment is made. Another typical problem with, this is actually a solution here. So setting this value in before each. Yeah. Another typical problem I wanted to highlight is loop variables. So still, as in normal Go code, loop variables, they belong to the loop. And as I said, first you build the tree of tests. So this specify doesn't really run the test itself. So what you will get when you run it is the last value of your loop variable, which is 5, and not really something you wanted to have. So the solution is as simple as usual. So you can create a local copy, you can pass it as a parameter, whatever you see fit. So another typical way is to panic in a Go routine. And when you panic in a Go routine, your code dies, your tests die. So what you need to do is you need to recover. So Ginkgo can catch this panic for you, can report it to you, and actually continue running tests. But it needs to be warned. It needs to be given a fair warning before you actually go into that. So one line can actually save you a lot of output and a lot of head scratching. So this way your tests actually catch the panic, can report on it, and go on. Asynchronous tests, as all asynchronous code, can bring quite a bit of problems. In this case, we do have Ginkgo recover, but the order of functions, the place where they fail, can be swapped. So in this case, you see there's 2 functions. One actually fails in a Go routine after some time, after half a second, and another doesn't really do anything, but it just runs a bit longer. So what can happen is that you get a very confusing error message that function which doesn't do anything bad actually fails, and you don't know why. And the answer is because your Go routine survived further than the function where it was called, and only failed when another function was running, which made Ginkgo report on the other function. So how can you avoid that? Again, very simple. You can actually make sure that your Go routines don't live any longer than the testing functions where they were declared. So for this, you use a special asynchronous syntax with func done. So passing a special channel done, which just needs to be closed when you're really done inside your Go routine, and will not allow the test to finish before this done is called. So this way, the function which actually fails will be reported, not the other one which doesn't have anything to do with that. So this one is a hard one. So I personally spent probably 2 days troubleshooting this little piece of code. But yeah, you get this experience for free now. So a bit more about my personal experience using these libraries. So I have positive and negative. So let's start with positive. So in Verve group, we've abandoned manual testing some time ago, and we haven't been happier since. So our tests are easy to read, fully controlled by our development department. They're quite simple, so we can structure them in a meaningful way. We can reuse code, so we don't need to do 100 lines of setup just to test one thing. And they're quite portable, so we can use the same knowledge we've acquired in other projects. On the negative side, all the gotchas you've just seen, they didn't come out of nowhere. I didn't have to invent them. This is all things that happened in real development, in real software development. So the complexity can be daunting, so you really need to look out for it after you've written several thousands of lines of tests, I would say. Before that, you are probably safe. So, and this complexity can actually damage readability if you are not careful. So you need to watch out for how much how much code you write, how dry your tests are. So we are getting close to the end. So in conclusion, I'd like to say that please write tests. This is a very good practice. This makes you a better developer. Write different kind of tests. Just one kind of test, just unit tests, probably won't cut it in a bigger project. And writing different kinds of tests, pick your tools, because not every tool is perfect for every job. So different tools should be used. One good example how to avoid most of the problems I've just described, most of these gotchas, is start with a broken test. Make sure the test actually catches the thing you want to catch, and only then make it green again. And don't overcomplicate your tests. They're not supposed to be harder than the code, as they often tend to. So seek balance between complexity, code reuse, and explicit declaration of what is going to happen. So here, you get all the code I've listed in this presentation in my GitHub. Make sure to look for the English branch. And you can also look at my previous talk, which goes into a bit more detail about the possibilities of Ginkgo. So it's Ginkgo Talk 2020. So with this, thank you very much. Thank you for your attention. I'm Alexander Egurnov, team lead backend in Verve Group Europe. And if you want to learn more about proper testing, proper Go techniques, write me an email, find me on LinkedIn. We are hiring. We are also hiring front-end developers. Thank you very much. And with that, let's return to the studio.